have, I mean, now I hope that it will be a very nice session discussing on the different experiences that different communities have had in terms of open data, their management of open research data. And we will see that data for us, as already Ana Belén has been discussing, is probably quite a wide word. Yeah? So we will have a first set of presentations on material science, on earth science, on medical, the medical domain. I think that, I mean, it's quite nice to see, I mean, this diversity. And then later on, we will have Cesar and Javier talking about more specific aspects of how the acquisition of data can be done, yeah, through the life cycle, and also in the end, I mean, the usual thing that we normally don't want to talk about, but we need to talk about in many cases, which is on how to protect things, yeah, I mean, and how to deal with these problems that sometimes, I mean, we as researchers are not always able to do properly, yeah. So, I mean, Javier will be quite inspiring on that, I hope. So let's start now with Eva Unger. You see the name over there, that is Jesper, who was one of the key persons who, on the work that Eva is going to present, but I mean, he was not able to join, and Eva has nicely said that she would be the one doing the presentation. So the floor is yours, and I will, I mean, appear on the last minute. I mean, if I see that you are getting late, just to appear and say, hey, you have just 1 minute left. Okay. Yeah. Okay, Eva, so go ahead.
So welcome everyone. So as already introduced, I'm going to be presenting on behalf of Jesper Jakobsen, who was actually the postdoc working actively on this project and the implementation of the database. We called the title of this presentation Crowdsourcing in Material Science, Creating a Collaborative Database for Solar Energy Materials. So this, in the beginning of the Greco project, we kind of had promised, yeah, we're going to, create some kind of database. And then the more through workshops and also the initiation of the project, the more we started to deal with the particular tasks and also tools available to us, we started to realize we actually don't really have, a direct path already available to us. So we started to create our own. When it comes to responsive research innovation, this ongoing process is really about aligning research and innovation to the values, needs, and expectations of society. And then you can look, for instance, at directives from Open Research Europe, which requires open access to research data, supporting articles under the principle as open as possible, as close as necessary. And then also just sentences like data should be deposited in data repositories in the beginning made us a bit wonder. So what specific data repositories could we actually be using? And how much use will those data repositories actually have? So obstacles when wanting to practice open science could be systemic, could also be individual. So we realized that in particular, the lack of established suitable platforms in specific scientific communities might turn the urge or the need to actually make your research data available more into kind of a, let's say, something you have to do instead of something you're choosing to do for the benefit of your own research visibility, as well as, of course, informing the society and spreading the word about what you're doing. Then on the individual level, it can, there's, lack of knowledge, but especially also practices, routines, and habits of practicing open science. And it sometimes also felt that right now there's maybe too much left to the individual initiative, So basically establishing procedures. And with this project, we also found when we started thinking about, so what exactly hinders and inhibits the publication of research data? And with that, we mean not only making the data published in papers available to the public by open access, for instance, but making research data directly available. And then we started thinking about it as an iceberg phenomenon. So when you think of a research cycle, right, in many labs, data handling is still a fairly manual and also individual endeavor. So you have the group leader, or you have maybe also the researcher that, kind of through reading and writing comes up with ideas. And then this person might also, of course, be themselves the ones in the lab. I try to indicate a certain, let's say, cultural and gender diversity and age diversity in this image. So basically you go to the lab, you take your notes, you do measurements, and then that might be not even well connected to the end, the data you analyze or the output you get from analyzing data that in turn may be stored on hard drives or floppy disks or USB sticks or single computers. So all in all, we find that in most research labs, there aren't really very sophisticated data management or data handling systems available or in place. So we estimated that just from our own experience that just about 10% of the data that we're generating from our research, we are making public through publication. And one of the reasons is that, of course, there is lots of data. I mean, the metadata, statistical data, low interest data, data we forget about, random data, irreproducible data, failed data, lost data, et cetera, et cetera. So there's a lot of data we can't really manage to all turn into relevant scientific narratives. But this data might actually still be very, very valuable to still make available, especially when it comes to having good statistics about all the experiments that have been done, to avoid that, for instance, experiments are being repeated within the same lab or in labs around the world, basically wasting public funding resources in trying things again that already have been proven 100 times that it doesn't work. So we think, and we started thinking about, we actually need to change our procedures and habits. And that also means we need tools. We need better systems for data handling. And this is something we started looking into in our lab very locally. But then this kind of also directive, if making more of our research data openly available according to fair data principles. So starting to wonder how we're actually going to do this, we decided, well, we need data platforms that actually the scientists would use for publishing and making their science available. And so after that, we decided, it was kind of in the beginning of when Greco started, I decided, because I thought more and more about what we need to do. And then by coincidence, a former colleague of mine, Jesper Jakobsson, actually was available to do and come join me in Berlin and do a postdoc on this particular project. And he is in a way, the perfect person for that, because he is a material scientist, but has quite advanced abilities also in data science, data handling, and programming, which is a skill set that you don't always find combined in the same person. So he started working on kind of tools that allow direct data dissemination, but also especially data visualization. Oops. When you look at the field we're working in, perovskite solar cells, there's about 16,000 papers published. So now we're just looking at the 10% of the data that's actually already public. And we've decided, well, if you take, even within these 16,000 papers, it's becoming really, really difficult to find information. So what we did is we basically found 80 volunteers, and these were PhD students and postdocs. They actually were super easy to convince because they saw the immediate benefit of going through just 200 out of 1,600 papers, 200 out of 16,000 papers, extracting all the relevant information pertaining to the device architecture and the device performance out of them and putting them into the same database. And in the beginning, there was essentially a data extraction protocol that's based on an Excel sheet where we had several categories. We started out with 100 and it just expanded and expanded. So in the end, you realize you have to really smartly parameterize every aspect of your experiment so that you can basically put it into a measurable. Now, the outcome I'm super proud to show you today is an online platform where it's not just that a lot of our 44,000 data points from this data collection campaign was collected, but also in partnering with the Israeli startup Material Zone, we actually managed to now have an online platform where we have data visualization tools. So this data is really coming alive. And what I mean with this is one of the things that always frustrates me is data that's plotted as kind of static. So this data set you can filter, you can add to it, you can upload data, download data, you can filter, plot it already on the platform with different categories. And then one feature that I particularly love is when you click on a data point, you're directly taking to the original publication by DOI number association. So this is a super, super nice tool, in other words, to find relevant paper, and all our students really appreciate it because it makes finding relevant information in this growing amount of information published very easy. Now, having most of the historic data collected, we wrote a scientific article about the project with all the participants that will be published open access. We went for a high impact strategy, and that's why the paper isn't published yet, because science rejected us. Now we're under review in Nature Materials or Nature Energy, I think. We are in parallel initiating a number of follow-up articles where we are using tools like Authorea in order to actually do a co-authoring approach. The database will be available at the perovskitedatabase.com or www.perovskitedatabase.com. The code that was used to construct all the functionalities of this database was programmed in Python and will be published on GitHub. And now with the data platform in place, the next steps is actually enabling direct research data dissemination. So uploading more experimental data, 90% of the data that isn't usually made public. And that includes, for instance, publishing data sets on Zenodo and then linking them via the dataset to the Zenodo document. We're expanding parameters to also enable collecting other types of experimental data. And we are, by initiatives like this one, trying to inspire researchers from related fields to do similar projects. We have, for instance, recently talked to a community that's more targeting LED research. And we are still finding strategic partners, but very important to us has become the Startup Material Zone, who has in a way a complementary mission to ours, but ultimately their platform is actually one of those few platforms that may enable you to have a, let's say, data streamline from your laboratory data acquisition all the way to public dissemination within the same platform. And that means, and that I find really attractive as a researcher, you might essentially in the end have to change the status of a data set, that you don't have to go through permanent reformatting up and downloading to different type of formats and platforms. All right, and with that, I want to thank all the 80 people involved in the data collection. We had about 30 research institutes, especially from Europe, but also United States and in China involved in this data collection effort. If you want to get access today, send us an email. We're going to make that possible. At some point, general access will be possible, but we've decided right now we have somewhat of a restricted access because we also are still in troubleshooting, removing bad data, and also making the accessibility and usability of the platform a bit better. With this, I'm looking forward maybe later for discussion. We have to go to the next talk.
Thanks a lot, Eva. I mean, we will move into the next presentation from Raul, and then we will have the round of questions afterwards. People were asking already for the links so that you can share them in the chat. Yeah, probably you can just do that. So great. I mean, it was a very nice presentation, and in fact, I think that it is quite useful also for as a next step for Raul, who will be talking also about some similar initiatives in other domains. So I think that this is very nice. Okay, Raul, go ahead.
Sorry, I think that you were not hearing me. I was talking with muted. Okay, so thank you, Oscar. Yeah, so I will give you a bit of overview of the work that we are doing in Reliance project in terms of extending the research enabling capabilities of the European Open Science Cloud. So basically, in short, the Reliance stands for Research Lifecycle Management Technologies for Science Communities and Copernicus using in the European Open Science Cloud. And basically what we are trying to do is to extend EOS capabilities with a set of very innovative but interconnected services that are already proven, let's say, in alignment with the European Open Science Cloud interoperability framework. So we are adopting some kind of holistic research management approach. So we are taking the whole research as a first-class entity in order to enhance the discoverability of the data, of course, including, for example, Copernicus. This is one of our main priorities here, but also to improve like the extraction of relevant information coming from the content of the research itself, and managing the whole research life cycle while promoting the fair and open science principle. So we are piloting and demonstrating the services via 3 earth science communities, and we will engage more via an open call, but always with the focus as well of leveraging in this Copernicus data. So in short, the objectives can be summarized in 4. First of all, we are planning to provide a set of a suite of services for the research lifecycle management. I will go into more detail about this, of course. Then, of course, we need to integrate with existing EOS services. So this is very important for us. We need to onboard into EOS marketplace, but also we need to connect to existing other ones to leverage the use of EOS services. We will demonstrate all of our services and the value proposition via these communities. And our, of course, goal as well is to increase the use of Copernicus data and the EOS impact as a whole. So going into more details, our portfolio basically is composed of three main services. First of all, we are talking about research objects as the overarching mechanism to manage scientific research activities and connected associated resources. So basically, research objects will be our core. I will give you a bit more on details on that because this is like the main core of the project. And the service behind that is called ArrowHub. So it's already an existing service, of course. Data cubes we are using as a mechanism to enable efficient and scalable access to structured data, specifically for Earth observation data. So there is a system already in place called Adam that gives us these capabilities. And finally, we are bringing services for text mining and enrichment to extract machine readable metadata from resources, like from the content of the research, and also to do some kind of recommendations. Okay, and the system behind that is called Cogito. So as I said, research object is like the backbone technology behind Reliance. So it's a bit important to give a bit more of context on this. Perhaps some of you already know or heard about the word research object because in fact it has been used in different contexts and, but basically the idea behind is research objects as rich information objects that aim to account, describe, and share everything about your research. So all the resources related to your research, and of course, the information about how all of these resources are connected to each other. So the main three elements of a research object are an identifier. So that means that you can uniquely identify a research object. You can, of course, associate a DOI. The resources, that means all the kind of artifacts that are associated to your research. That can be, for example, the hypothesis, the data that you were using, the methods, scientific workflows, provenance, and so on, including, of course, the people as well. And the annotations. Annotations are basically the kind of description of the resources or the research object that are not just human readable, but also machine readable. And this is like the main overview of, there is a lot of movement around research objects. There is a ArrowCrate activity that is continuing on this direction. So bringing people from many different areas and continents. So, okay, so based on that, the main logic behind this Reliance architecture is like you can see in the diagram here. So in the middle, you see the services providing the research object capabilities and functionalities that are interconnected with the data cube services and the text mining services. As I said, all of these services are having some kind of interconnection. So we are, for example, taking the data cubes as a also very important entity in the research object. And all of them expose REST APIs, libraries that you can use in notebooks in Python, or that's what we are working on, of course, so that they can actually be used by many different user interfaces. So that's the idea. At the end of our goal is that everything can be managed via the research object, but that can be exposed and used through those APIs or libraries that we are exposing. And of course, also, as you can see in the diagram, we are connecting to EOS, of course, some of the cross-cutting services, but also some of the added value services, as I will show you in a second. And as well, one of the things that we are interested in is the use of notebooks as the kind of execution environment to support the earth scientists, let's say, processes and simulations, whatever they need to do analysis on the data. We are using notebooks as our main tool, where they will be, also able to access and use the research objects. So at the end of the day, if we see this from the EOS perspective, Reliance services are going to be acting some kind of a bridge between existing ones. So because we are connecting, things like from the data that is used by researchers, for example, provided by repositories like B2Share, Data Hub, and so on, to the methods that, for example, can be used via the EGI Jupyter notebooks, to the research infrastructures that are used to execute all this research, to the results that are published in repositories like Zenodo or OpenAir, of course. So we are connecting all of these pieces together. That's what the research object is doing. And of course, during the life cycle of the research, we are able to generate some kind of a snapshots, we call them. So it's like intermediate releases of the research, so that this is actually improving and making faster the publication process, so you don't have to wait until the end of the research is already finished, done, whatever. You can do faster publication process. So this is something that we are doing here as well. So this is a very simple scenario that you can see how this will put into practice. So imagine Federica is a marine scientist that is actually monitoring the marine environmental variables from the Marine Strategy Framework Directive, and she's very interested in analyzing all of this data that was generated through this historic time of pandemic, to see what was the changes, what happened, you know, with the sea monitoring, the seas that she's monitoring, and so on. So Federica, for example, can start her work using this Hub repository, create a new research object. This will be like the container, this logical container where she will encapsulate all the resources, material that she will be used to the study. She starts collecting and annotating relevant bibliography into this research object, and then through the use of text mining, we will extract information that will be relevant from these publications and bibliography that she's put into the research object. Then she is going to run typical processes using the GUIs that she normally used, for example, to select the relevant in situ and Copernicus data to work with, and also to to start to doing some kind of analysis on that. And in order to do that, she will be using the APIs that we are providing, right, in order to keep in sync all this material with the research object. She can, of course, take advantage of other EOX services, for example, resources or data that are available in Zenodo or in B2Share, for example, but also she can use the Jupyter notebooks, like I mentioned. This is another EOX service that is already available. So she can access the research object from there and start doing her job. And at the end of the processing, she will be able to save back all her work into the research object. She will be able to do some kind of versioning, keeping track of the entire research lifecycle evolution. And if we go just quickly onto this, like another
Raúl,
yes,
probably. I mean, you can. You
yeah.
can try to finish now. If you
Yeah,
can.
sure. Okay. So
Yeah.
what I'm just going to say here is that there is another researchers in another part of the world that can do, some similar kind of work, complementary, and she will, take whatever Federico was providing, and using all the tools and the research object at the back, they will be able to share and continue their work together. So this is our communities. So we have, like I said, 3 communities: sea monitoring, geohazards, and atmospheric communities, and the partners of the projects that you can see here. So with that, I'm happy. And sorry, I move a little bit beyond the time slot, but thank you very much. And of course, I'm very happy to give you some answers.
Okay, great. Thanks a lot, Raúl. I mean, I will collect comments and questions that are appearing already. Kes, in fact, was already talking about AeroCrate and how nice it was. So probably, I mean, he has now the floor. The floor is yours as well. So he will be talking about the medical domain. And I think that now, I mean, we have a really nice overview of many different disciplines. So Kes, go ahead.
All right. So yeah, thanks for having me here. This is actually very exciting to be in an open science meeting. I tend to be the odd guy in the room that's talking about this thing called open science. And now here we are with all of the open science people. So I even got it into the mission of the company, the Hive, that I founded. So what we do is we enable open science by developing and implementing open source solutions, biomedical open source, and by also verifying data, making data fair. And one way that I like to look at open science is using this graphic that I borrowed from the University of Utrecht, actually my alma mater, which really shows nicely this transition from, science as a sort of isolated activity, of course, cartoonesquely speaking, but transitioning to science having a real societal impact. And where better to look than in this time of COVID at medical evidence? Because do you remember this time in the beginning of 2020 when we're all trying to figure out what is this new virus? how does it interact with existing conditions, with existing drugs, which drugs work and which don't. You have the President of the United States going on stage saying that, this drug works, trust me. And so it became more important than ever to generate evidence on what works and what doesn't in a reliable and transparent way. And this is exactly what we did last year in the Odyssey community. And I'm going to show you that. But before I can do that, I have to give a little bit of background on sort of how and some of the technology. It is an open data session after all. Yeah, okay, I'll skip that. The problems in open science. So the example that I'm going to give is from one of the pre-competitive projects that I have instigation is called EDEN, European Health Data and Evidence Network. But we also work in many others. Again, I don't have time to cover that, but some of these other projects use the same principles and communities. So EDEN, what we have is a very focused group of a few universities, public bodies like NICE in the UK, that's looking after the healthcare guidance, and a number of pharma companies. And our goal is to create an open science European network of medical data sources, so that, for instance, the European Medicines Agency can come in and easily and quickly do observational studies. That is what we're doing, and actually quite successfully. Our original goal was to have 100 million patient records in Europe mapped to OMOP, which is a common standard. Actually, we are halfway the project, and we're already at 300 million healthcare records at the moment, which is great. We use incentives, monetary incentives. So, we give out grants for data sources that want to map to this standard. We also train small and medium enterprises all over Europe in these standards. So this is how we do it. But really how we are able to do this so fast is because we are plugged into an open science community that is global. And it's called Odyssey, Observational Health Data Science and Informatics. To my knowledge, it is the largest community in terms of number of patient data sets worldwide and have been mapped to a standard. And this, again, mapping to standards is very important. If you know the FAIR principle, this is about interoperability. I will show you also a little bit how that works. The standard itself is a model that focuses really on observational research. So you have just generic health facts like procedure occurrences or people taking medicine, blood measurements. No matter whether you have data from a GP practice or from an electronic health record in a hospital or from a let's say a registry like a cancer registry, they always will have these kind of health facts, and these health facts are very useful for a whole range of studies. The other thing we also have in the Odyssey community that we work on in EDEN is the mapping of local data sources to or standards and terminologies to the Odyssey, what we call standardized vocabularies. And then lastly, the third thing that we have developed in this community is a set of standardized analytics for important epidemiological use cases. So then we changed this virtual meeting into a study-a-thon. So this is a virtual event in which we looked at a number of research questions, and we also had data from, for instance, New York, which at the time was a hotspot for COVID, several European data sources that were already mapped to the standard OMOP. And we looked at 12 questions. And one of the questions was indeed to study the safety, not the efficacy, but the safety of hydroxychloroquine. And that study was done like literally in a week. We were able to do it. And then a few days after, we also published a preprint. And we published the data as open data with all the statistics, the hazard ratio, etc., so that you could look into this. Now, this had a real impact because just a few days after this preprint was published in medRxiv, it was already picked up by reporting like this article here in Science Magazine. And this is a super interesting graph. It shows you what the uses of hydroxychloroquine. And you can see that if you look at the timeline, our study was published in April 10. It was also cited 2 weeks later by the European Medicines Agency as one of the studies that showed serious side effects of this drug in certain populations. And if you look then at these lines, those actually show you the in-hospital use of the drug. And you can see that these preprints and these warnings directly, indeed, we see back in the data from hospitals that people or doctors stopped prescribing them and people stopped taking them. And so even though the official Lancet article, which eventually would come out of this, was published a month later in November, you can see that the open science, us publishing the preprint, the data, it was picked up by the EMA, it was picked up by doctors, and we didn't even have to we did the publishing process, but it wasn't the main societal result. That happens already after the preprint. And again, this is just a hydroxychloroquine, but we did a lot of other articles as well, like this one on the ACE inhibitors and COVID. So yeah, I hope that again, it was a very short time to compress this in 10 minutes, and there's a lot more to say. I have put some links here, but I hope that I've shown you that medical evidence generation is really changing from sort of the old paradigm. Let's publish one study where we look at one research question in one database, to a systematic open analysis, which also deals with this problem of p-value hacking, and really hopefully leads us to more reliable evidence. Thank you.
Thanks a lot, Kes. I think that it has been really inspiring as well. I'm very well connected to the initial presentation from Eva, and also with what Raul has been presenting. So I think that we will have a very nice discussion now in the panel. Yeah. Okay. So I get now into Cesar.
Sorry,
okay, Cesar, go ahead. Yeah. Mm-hmm.
Okay. Thank you. My name is Cesar Dominguez. Thank you for inviting me here to present some ideas at this webinar. I'm an associate professor at the Technical University of Madrid and a researcher at the Instituto de Energía Solar, which is participating in this Greco project. And in my talk, I will try to illustrate how open data can be managed in the particular field of photovoltaic science and technology by researchers that are not that fluent in these cutting-edge tools that have been described in the previous talks. So I will begin by discussing what I perceive is a reluctance to open data by average researchers like many of us, and then I will move and try to describe how we deal, or we should deal, with preparing and publishing results for open data publication. So the benefits of open data, I think, are the theoretical benefits, I think, are clear for many people. They are there, or this open data approach is there for improving science quality overall, because it will improve transparency, traceability, reproducibility of science. It will improve the credit you receive for your experimental data, otherwise not published. It will increase research efficiency and productivity, because many other researchers or other stakeholders can benefit from your data. It can help bridging knowledge silos that do happen in science. You often are very close to the particular community you deal with usually. And in principle, it can increase citations and potential collaborations that helps to discover. The overall goal is to facilitate knowledge discovery and innovation. But still, despite all those wonderful promises, I perceive a reluctance for open science or sharing open data. And the truth is that, I divided them in two groups, just bear skepticism and fears. I think many researchers feel that just this simple question, why should I give for free data that has a cost in acquiring and publishing if I cannot, if I didn't took all the value from it? And I think this is the old perspective, right? But actually, will that data be useful for anyone? Isn't this another burden from policymakers of people that are not connected to my research field and doesn't understand how it's really putting pressure on me, on researchers' shoulders? Will I be actually rewarded for adopting open data? And I think this has to do, of course, with the institutional change that we talked about earlier this morning. And especially with industry partners, is this useful? And the fears are, can others can take this data and claim priority of my results or any hidden knowledge that I myself didn't discover on it? Can open data invalidate a future publication or patent? Will I lose my competitive edge if I'm sharing my costly developed models? Someone can discover any flaws in my data or research. I'm afraid of losing credit. Or even this credit can happen to our industrial partners if we are sharing sensitive data that can affect their business case. And I think all those fears can be actually partly true. I mean, this is in the current institutional situation and science picture, can be partly true, because if everyone plays their business as usual, we are trapped in this in game theory. This is what it's called this suboptimal non-cooperative equilibrium, where everybody is trapped in this suboptimal position, and only an institutional change looking for a larger common good can help us leave those traps, actually. So even if these are concerns in general, particularly for the field of photovoltaics, these benefits are also hard to grasp because of some key characteristics of photovoltaics research. This is, for most groups that I know, this is a low throughput bench science with a lot of small diverse data sets that make documenting, formatting, filtering, or publishing costly and hardly reusable. Especially if you invest time in metadata, it's hardly reusable. The experimental setups are evolving, so the consistency is difficult, interpretability is difficult, and completeness of data is often difficult. So you have to invest time to make your data sets actually valuable and reusable. If you work with industrial partners, which is mostly the case, most often the case, you have to be careful with sensitive data, and all those standard tools from that are related to open data publishing are mostly related with data-intensive science fields like life, climate, or social sciences. And I've prepared this bad scientific joke that tries to show the way many of us, the old school researchers, feel when encouraged to do the open science thing. We are there on the top of the mountain of difficulty, dealing with all those new terms for us, trying to make our data as open as possible, but we are envious of the freedom of the consultant or the private researcher making great discoveries and money out of data that is never disclosed, and they are happy about that. And also envious of those life science or climate scientists dealing with trillions of data using cutting-edge analysis tools without any effort. But we cannot be in any of those sides, because we have to find this sweet spot between sharing our knowledge and protecting potentially exploitable results. This is our trade-off there. So, and we sometimes find or feel that this is not fair, like in fair open data. So still, we feel that there is a lot of open data that we can share, and we have been trying to share during Project Greco, raw experimental data, processed data, metadata. If you're dealing with sensitive data, it's still valuable to share metadata, equipment lists, setups. This is interesting for many other research groups, your methods, your procedures, any tools or code you produce to deal with your data. The rule of thumb is follow your project's data management plan. And you can, for managing this open data, you can follow a simple checklist or decision tree. If data does not exist yet, make it open by design. If data is not digital, digitize it using media types. If data is in a proprietary format, convert it to an open format, CSV, open documents. If you don't have the rights to make data open, consider publishing a metadata as a data codebook, as a guide to what is measured, what has been measured, and what can have a value for other people. If data set includes sensitive data, you can ask for permission to share under certain limitations. Fair doesn't mean open always. And if data can be openly shared, try to publish it under some copyleft license, attributing or not, using FAIR principles in a stable, recognized repository. So the first thing to do when considering open data publication is to prepare your data set by following these simple rules. Experimental data, that usually involves spreadsheets, use one spreadsheet, one separate file. Use simple text files, CSV if possible, other open formats, variables in columns, observations in rows. First row to describe headings. Differentiate null and zero. Do not include calculations or graphs. Apply quality filters where possible. And it's also convenient that you create, in a separate file, a data dictionary describing the variables, units, ranges, valid ranges for those data, and consider trying to use a standard dictionary for it. Like there are taxonomies or ontologies that are that have unique resource identifiers that you can share, and that will improve the discoverability or reusability of your data. You can also consider a separate README file for describing your setup, your data set, the details for the filtering steps that you took. All these will improve the reusability of your data.
Cesar, I'm conscious about time, so I mean, just try to finish up if you can. Yeah.
Okay.
Sorry about that.
Thank you. So what we do is we use Zenodo to produce this findable, accessible, and interoperable and reusable data, because it allows for creating the appropriate metadata that is indexed. It allows you to use a REST API for accessing data. It uses standard JSON schemas for the metadata, and it's reusable because it helps reusability because it's the information uses these standard terms in DataCite. You can also check for the quality of your open data using standards like the Open Data Certificate from the Open Data Institute. You just put your URL and you will get this quality control. If your data set is not complete, you can create an open data web portal, as we did with Postgre and Plotly. We publish our code by default using GitHub because it allows control version and GPL licenses. And I'd like to finish with this anecdotal evidence on the feedback on trying to publish an open data, a protocol as open data. We published in this journal specialized in visualized experiments, just one of our characterization techniques. And if you look at the usage statistics, it has been read by more than 5,000 people from many very relevant institutions around the world, from which we have received exactly 0 citations. And in the current institutional rewarding scheme, this efforts on collaboration or contribution to science excellence is not valued, is not rewarded. And actually, this paper has contributed negatively to measure the impact and quality of our research in a recent important research grant called María de Maeztu. Thank you.
Okay. Relevant, interesting problems as well. I mean, also a nice cartoon, yeah, that you presented, as people were commenting on the chat. So we go into the last presentation from Javier. I have seen him among the list of participants already, so he was able to enter. So Javier, can you?
Good morning to everybody. And I have to say thank you, Oscar. Thank you very much to everybody, and thank you for the invitation. I'm trying to be quick because we are out of time. As I do hate presentations, the only thing that I'm going to do is I'm going to share some bullet points which are in my website, just produced with my Emacs, and this is Twink Twink for Linux users. So let me check, how can I
all school Linux user, good.
Yeah, but the thing is, here it is. I think that this is going to work, and if it's not, please let me know. Are you able to see inspiring researchers on the use of? Okay, the typical. Perfect. Yeah. Okay. So yeah, the 2020 and 2021 second question, which is, can you see my screen? The first one was, do you hear me? So, I am my background, in order to understand what am I doing here, is I've been 32 years practicing law. My last 15 years have been, 20 years have been dealing with intellectual property things, and since 2000 I am a Linux user. So one day I discovered that I had this blue screen of death, and I wasn't able to understand what was happening inside that computer, that I had paid the license, and that it just destroyed 1.5 hours of a very meticulous work that I had to do. And even paying the license, then I read the license and I said that, oh, they are not responsible for that, and I cannot understand why this has happened. So then I discovered Linux, and this was around 2000, the year 2000, and 10 years later, well, 5 years later, I was administering system servers, Linux servers, and then later on, as I understood, was I saw that law is not enough in order to understand what is happening nowadays with all the changes in the digital. Then what I did is I studied a master and a PhD in philosophy that was oriented absolutely to open science, to open data, and to open governance. Already in 3 European projects, as by my own, not with another institution, but as Javier de la Cueva. And what I have been dealing is with intellectual property rights, with sustainability and governance of research, digital platforms. And now what I am going on is into responsible research and innovation. Okay, so to be quick, what are the problems that we face when we want to build up an open science? Well, we have to face a 200-year historical tradition, which is that the only way to protect intellectual property is to put barriers on it. That is to say, we're going to avoid the rest of the world to use something that is mine. And this is the typical image and tradition that we do have about tangible things. That is to say, if I've got a car or if I have a house, what I'm going to do is I'm going to put barriers, I'm going to put fences, I'm going to put security guards, and I'm going to call the police so nobody could be able to trespass it. The problem that we face with the digital is that what we are speaking about is that we are speaking about 2 different things. The first one is a list of zeros that can be executed, and the other one is a list of zeros that is only data. The first one is called software. The second one is just called data, although software is already data. And then in this data, the general rule and the default rule that we do have is that if nothing is said, then by default, everything is forbidden. And intellectual property, what it does, it focuses on 4 different activities. These activities are to copy. The second activity is to transform or to make derived works. The third one is to public communicate, which is to communicate to the public in a way that you do not give tangible things. And the fourth is to distribute. That's what we do with books or with those printed objects or with an USB stick. That is to say, we give atoms. We give atoms plus the data. So the default system that we have is that everything is forbidden. Absolutely everything is forbidden. So how have activists done in order to open the knowledge? If everything is forbidden, then that is bad for dissemination. So what we do is we face a same system, that is the international property laws, which are like a hierarchical system. And in the top part, we do have the WIPO agreements from the 19th century, but we do have also the TRIPS agreement, which is from the 20th century. And the TRIPS agreement, what is saying and what is focusing is only on commercial things and only on things that can be sold or can be traded upon. So TRIPS agreement is focused on trade. What is the problem that we face now then? That what we do is we live not on things, what we live is on process. So the traditional copyright, what they did is they protected things that were static. And now what we are facing is that all the systems that we are producing in science, is the biggest one, is made with things, with processes that are absolutely dynamic. So the approaches that then we have had in order to open knowledge have been, well, there have been certain, we could say, very well-known systems where we have this problem of open access to journals that came in the Budapest Declaration that was from 2001, I think. And then what we do is now we are facing this openness in data, which is, we could say, the 2020 aspect. We are with this fair data, but we have to also think about free software. And then there are certain problems that we have to face, which are APIs, taxonomies, ontologies, and hyperlinks. So, and text and data mining. So what are the problems that we are facing nowadays with intellectual property, and why we have to be very aware of these problems in order to allow knowledge to circulate? As said before, everything is forbidden if you do not have a consent. So by default, everything is closed. How to open it? Well, we do need licenses. We have to license every piece of information that we are using. What we have to do is we have to put a notice, that is to say a license, letting the other people know what do we allow to do with the data that we produced, or with the article, the journal, what we produce. And when we arrive to free software, this is a practice that has been done since long time ago. Free software has plenty of lessons to teach to science and to teach to data nowadays. Free software has a long tradition of knowing that there are libraries, that is to say, part of the software which we are going to link to. So what they do is there's also specific licenses for libraries, and there are also specific libraries, specific licenses for the trunk, for the main part of development. So what we have to do is we have to use free software as an example of interoperability, because whatever is the problem that we find with interoperability, free software has already solved it. And we have to remember that the General Public License version 2 changed into General Public License version 3 because they were aware of the problems that, for example, software patents were posing over software development. But there are certain things that here in Europe we have to be very careful also. The first one is the APIs, taxonomies, and ontologies. And why? Because we have a special regulation related to databases, and it is a directive from 1996 from the European Union. And what we are doing is when we transmit with an API some information, it is not only the information what we are transmitting a certain structure of the information. It doesn't matter what is the protocol if you are going to use. If you are going to use REST, it's okay. It doesn't matter if you use XML, if you use JSON, it is exactly the same, because what you are transmitting is a particular way of understanding the world, of understanding knowledge. That is to say, surname, name. If it's North American, we're going to put middle name. If we are going to try to have two terms that we can distinguish what do they mean, then we put this fourth element, which is going to be nationality. So then we know that the second part is of the name is a middle name and it's not the first name. And this is a special problem, for example, for Portuguese, who they have their mother surname, the first one, and we Spaniards have or Latin countries have Spanish. Sorry, the first surname is from the parents.
Javier, sorry to interrupt you, Javier, but I mean, just in conscious of time as well. I mean, so if you can.
I'm just finishing, because I'm just going to say that. I'm going to say hyperlinks, text and data mining, and I'm going to say what is the problem. That's it. So I need only 30 seconds. So this is then a representation of what we do in data. And this is exactly the same with hyperlinks. There is a resolution from the Svensson case in the European Court of Justice that it says that to link, that is to say what is the metadata that is applicable to another piece of information, is also a public communication. And last, about text and data mining. When we do text and data mining, the exception that we have in the directive of 2019 is that it's only for scientific organizations or heritage organizations. And this then is something that we have to be very aware, because those are the limitations that we have to fight against and put always licenses, so then we allow our work to function. Thank you very much.
Thanks a lot, Javier, and sorry for making you go faster in this last part. I mean, it's always a challenge, just to handle this part related to the licenses and on the rights and so on. Yeah. So we have some open time for discussion. There have been plenty of questions that have been appearing on the chat. So I think, I mean, I have tried to, to get some of these questions. I mean, and probably we are not going to be able to handle so many of them. But I think, that one of them that has been appearing and where there has been already some discussion is related to the PIDs, the idea that, we should have, or all these collection activities that are being done, that Eva has shown, that Kes has shown, that Raul has shown, they would need to stay on in time, just to make sure that we can really provide some benefits to science. And that the current means that we have, like for instance, Zenodo, that has been commented by Cesar, probably, they are not the best places where to go. So is there any of you, Kes, Eva, Raul, as you have been discussing on this, is there any point that you would like to make in terms of which are really your needs and which are the expectations that you would have in terms of these permanent IDs for data?
Yeah, so I mean, it's a big topic, and we can't just solve it in a few minutes. But
I don't think so.
I'm trying to be humble and cognizant of everything that's possible, but also just being honest that I don't think we have cracked this problem yet. And we are definitely making a lot of progress, and a big part of the whole movement of open science and FAIR is, of course, to make people aware of these issues in the first place, to have data management plan. I think there we're doing great, projects like FAIR is FAIR and others. Also really exciting are some of the technological developments like OpenAir, which you can do if you build a knowledge graph, right? That the OpenAir graph. But if we really want to extend this, then we need a sustainable way to preserve the scientific data. And it's a bit like, if you think about the 1,000 genomes, we have the university have so many disk capacity, network capacity, but where are in the end our 1,000 genomes data set hosted? in Amazon S3 with a US cloud provider. And so now the proposal of a lot of the, even in the name European Open Science Cloud, it's like, yeah, let's copy this to Europe. Let's try to wrestle some of this control of the cloud services from Amazon and Google and set up a European Google. I don't think that's really the answer. You know, to me, a much more logical answer would be to go the way of Web3 and think, you know, how can we have a strong network where, yeah, I'm a university, I have this capacity, so I can also host some nodes. But that really means that you have to push these things to the protocol layer, and they have to become very, very rock solid and stable. And if you think about a service like, you know, what was it, the B share, or those APIs keep changing, and we have to rely that there's maybe one university somewhere that is hosting this thing, and that's also not the solution. So yeah, that's I don't have the answer, but I'm looking in Web3.
I'm just wanted just to complement that I mean, this is something that is in fact supported, or like in the vision of the research object itself, like we discussed. I mean, in the sense that the research object is just you know, connecting those pieces that can be, for example, in a repository in a university or in another place in Zenodo or whatever. And of course, at the end of the research object can also has its own identifier that links to everything that is below. So, you know, of course, the topic of the identifiers is a very important one, because it's a very difficult to understand. For example, what will happen if one of those pieces of information is missing, is no longer accessible, is changing, and that kind of things. But you know, that's the kind of topics that we are trying to deal in projects like also in Reliance, for example. Yeah.
And the way IPFS does this, again, I'm so enthralled by this technological innovation, but it's basically using the hash of the content as the identifier, and then having a peer-to-peer network to share that. And it's big, it's massive. You know, there's terabytes and terabytes of data already, but it's mostly known in the blockchain world. I just see a massive potential to start using some of that for science.
Yeah. That could be a very interesting option. I mean, it also combines the technological with the organizational parts. Yeah, that I mean, like we have been discussing quite a lot in the interoperability framework in terms of all the needs here that we have in that context. Probably, I mean, I would like to move on with other comments that are appearing. I mean, they are related to, I mean, like for instance, data ownership, and at the same time with some of the practices that I have seen. Yes, many of you have been presenting practices that are related to what we call sometimes stamp collections, yeah? Finding data sets in research publications, or going into doing a study-a-thon, or I mean the name that we want to put it over there, where we are showing the need to collect data sets, to understand the data sets, and probably also to understand that metadata, who it belongs to, yeah, because they are surveys, yeah, and probably, I mean, this would be very relevant also to the comments that Javier has been doing. So, do you think that this is something that is well recognized by the community? In the end, I mean, what you have shown is that you write papers that are survey papers, yeah, but I mean, you cannot be writing survey papers all day long. Or if you generate this data set, very nice data set of materials in material science, I mean, it will be a nice asset, but I mean, how do you maintain it? So what is your view in this context? Probably for Eva, Kes, also, I mean, in terms of the metadata for Javier, and also, I mean, Joe was from the people who are attending, she was also commenting on this. So what is your view? Mm-hmm.
I actually have a direct question to Javier, if he's still available. Mm-hmm. So in this, I mean, in this whole, when we started basically going through the literature and looking and extracting data, I call this data digging and not data mining, because it's really, you know, spade and shovel. So we actually discussed the whole aspect of who owns the data. And I was also trying to discuss this with the editors of scientific journals. And in my understanding, and from all the legal aspects, that scientific journals or even book publishers, they own the copyright of how data is visualized, but they do not own the data itself. Is that correct or not?
We will submit that. I mean, because I have also important doubts on that as well. Yeah. Mm-hmm.
And I guess the other thing is, I mean, our goal was never, right, to take data. So we concentrated on already publicly available data for the reason that we felt this has been made public. The intention was of the authors to spread the knowledge and the know-how of what they've done, right? So we're creating basically a tool of making the data even more visible and findable and accessible. So we're doing them a service. And this is why my feeling is, we're basically not doing anything that is negative. We're doing something that's very positive. However, when it then, of course, comes to unpublished data, you need to give the origin or the authors the ability to choose what they make available. But even here, I think training and showing cases of, how to make more of the data we're producing accessible, how to publish more data sets, I think is really important. So go more towards the practice of publishing every single data set we're producing. So that's what I'm trying to enforce in my team right now, that I said, okay, every solar cell you're making has to go on the database at some point.
Okay, yeah. So Kes, you were commenting that especially, that there are also companies funding research over here. And then, we have to be careful with that, yeah? So sorry not to be able to continue the discussion on this, but we have plenty of comments over there on the chat. Probably we can take that opportunity to collect them and then continue the discussion offline.